So if you recall, in our previous lesson, we talked about the server-side implementation of our Flight's Monolithic server, or Flight Monolithic app, which is the flight listing app, or FLAP. And what I'm going to do today is show you the client-side implementation, or portions of the client-side implementation, because it's rather vast. And we're going to use an Android implementation. So I'm running this in my Android Studio. And the first thing I'm going to do is I'm going to go over to my terminal, and I've CD'd over here into my Flight's Monolithic folder. And I'm going to go ahead and run the server. So I'm going to use Gradaloo, and I'm going to say boot run. And if all goes well, then this will go ahead and start up the server. So the server is now actually running, and this is the server that we've looked at in previous lessons when we walked through the code and showed you what the server was doing. So the server is now up and running. Now what I'm going to do is come over here to the client side, and I'm going to go ahead and start up the app in the emulator, and hopefully it'll work. So let's go ahead and sign in, and we're going to say admin with the password pass, which is pretty lame security, but it's working. So now we go ahead and we log into the app. Now keep in mind what's happening here is this emulator is running on, well, they're all running on the same machine. The server's running on the same machine that the client app is. In real life, of course, that could be, oh, come on. It would be running somewhere else. So then what we can do is we come up here and we click on choose the departure airport, and we'll just pick one. Let's leave from Athens, Georgia. And then we'll go ahead and click where we want to go. And let's say we want to go to Baltimore, Maryland. So what has happened when the app first started up, it went and did a call over to the server and said, tell me all the airports that you're aware of. And then those were the lists that were populated when we clicked on those widgets. And then we can go ahead and select the date to travel. Let's say we're going to leave on March 14th. These were also kind of pre-canned. And we're going to come back on March 17th. All right. And then we can decide how many passengers we want. So we can click 1, 2, 3, or whatever. We can, let's say we want 2 people. So at this point, now we're ready to make a call to the server. The application has already made some calls to the server when it started up to get the list of airports and to get the departure dates. But now we're actually going to make a call to find flights from that airport, from the departure airport to the arrival airport on those dates. Whoops, let's go ahead and make. All right, so now let's go ahead and find the flights. And you can see here that we're going to get some choices. Let's say we pick the cheap one. Why wouldn't you pick the cheap one? And let's pick the returning flight. Let's pick the cheap one. And so then we're going to go ahead and have departing and returning. And then we have a total. Now, if we actually had implemented this to be connected to a database, when we clicked, reserve, it would go ahead and book the flight. We haven't implemented that yet, but it gives you a nice feeling for what the app looks like and kind of how it works. And I think you'll agree, it looks very much like an app that you would use if you were like going on Southwest. That was our inspiration for this whole thing was Southwest. And let's see, just change around these things at all. Anyway, so that's the GUI for this thing. So let's go ahead and move that out of the way. And then I want to show you some of the client-side code. Now, there's a lot of code here, and some of the code does things like the authentication. When you log in, there's an authentication step that goes on. And if you watch this week's videos, you'll learn about authentication and authorization and so on. And this part of the code here is the part of the code that does all of that stuff. This is a web login, web-based login, a web view framework login, which works nicely for the monolithic apps. I'm not going to walk through all of this code. It's pretty low-level, grubby authentication code using OAuth and so on. What I will focus on will be what happens once you're logged in and then the program starts to do cool stuff. So This particular entry point is really the main business logic for the app, and we've implemented it using RxJava, which works fairly well. It's not perfect. The Project Reactor is actually cleaner, but it works okay for what we're trying to do. So it makes things fairly asynchronous. We use these things called live data to keep track of the various resources like airports, flights, dates, and so on. And those are the things that are displayed visually on the screen. And then we bind to various fragments. So you see we have fragments. If you look over here, you'll see that we've got fragments for finding the airports, finding the departure dates, finding the flights, logging in, and so on and so forth. And we'll talk about some of those when we get a little further down here. So we're setting up all this data. A lot of this stuff is really just to interact with the user interface. And then let's go down to something that actually does something cool. So this is something called data source. Data source is an instance of remote data source. And a remote data source is essentially a remote data source adapter that handles all the logic for invoking these RESTful calls on the flight listing app, on the FLAP endpoint methods, and also to manage the tokens for doing authentication in conjunction with the web view. And you can see here that we have redirection for logging in and authentication. We have the base URL, which is just running locally for this example, but you could always make it remote. Bunch of stuff here for OAuth. We are a client. Some other things for OAuth, authorization code, refresh token, codes challenge method, blah, blah, blah. We have a default timeout, which we're going to use to not wait forever. And then we get to some stuff that's actually more relevant to the server that I showed you before. We have a flight API. We'll look at that in a second. And that's really going to be the main way that we contact the server. Let's go take a look at Flight API. Flight API is just an interface which defines these endpoint methods as string constants. So you can see things like, log out, airports, dates, flights. Those are obviously going to be things that the server is going to know about. And then down here, what we do, this is pretty cool. This is an interesting capability that essentially uses annotations to encode requests. So we don't actually have to write any of this code ourselves. This is all going to be auto-generated. So we're going to say, there's a request token method that will be converted into a post request, and it'll be encoded with this format. And if you look up here, it talks about the format encoded annotation is used to indicate how the request body should be encoded. That's meant for post request. There's a get annotation that is for get request. There's a query annotation that's used to define parameters that are appended to the URL for the get request. So we come down here and take a look, for example, let's skip over the token stuff. When the app first starts up, as we'll see, it makes a call out to get the list of airports. And we don't have to write that code. That's generated automatically by this get annotation, which says, go to this URL that's running on the server, and it'll return a single, which is an RxJava asynchronous capability that will emit a list of airports. So we're going to get this back as a single to a list of airports, and you'll see how that gets used in the code. Down here, there's another method called get departure dates. As you can see, that is a get mapping, and it's got the dates URL, which we saw before, and it takes two query parameters. One is the departure airport, the other is the arrival airport, and it goes out and it finds all the departure dates for those particular pairs of airports. And it comes back as a list of strings, which are the dates, and it is wrapped up in a single, so it emits a list of strings. There are equivalent other get methods that we are auto-generating here, like find flights, where we take the departure airport, the arrival airport, departure date, number of passengers, the currency, basically the stuff that you see on the interface from that little Southwest-like Android client we looked at. And that returns a single that emits a list of flights. And then the final method we have here is one that will be used to log out. So that's a post request, and we're going to tell the client to log out. So this, again, is all sort of auto-generated. We don't have to write all those things. And this is using something called retrofit to do all the heavy lifting. All right, so let's go back over to the remote data source. So one of the things we do here is we set things up so that we're going to be able to use RxJava. You'll see how that gets used here. It's really cool. There's also a similar kind of Project Reactor adapter, and when we get to the Project Reactor part of the course, you'll get a chance to see that. You can see down here, here's remote data source. We're going to tell it to go ahead and, this is the constructor for this thing, build the API. And this goes out and basically makes a connection to the server and is going to use this HTTP client, which you can see down here. I think it uses OK HTTP. So that's setting up all the low-level details about connection timeouts and read timeouts and write timeouts and so on. We set up our RxJava adapter so we can use RxJava calls here. And then we go ahead and build this, and we're going to return a Flight API instance. And of course, we'll look at Flight API in a second. So that's really the thing that does the bulk of the calls to the server. So here, let's go back to remote data source. Let's come down and take a look at some of the methods that are. So this is how we're going to build the login URL. This takes all that information we need for OAuth, and it stuffs it up into a URL that we're going to build up here. We're going to build that so we can start off the authentication process. Here's the get airports method. So we'll see where this gets called in a second. This is actually going to get called from code that's connected to the GUI. You'll see it if you take a look at the, go ahead and do, what is it, usages. Let's say find usages. So this is called in the main view model. It's going to go ahead and end up calling down to get airports. And all the get airports method does is it simply forwards to the API, which is the thing that actually talks to the server, and it returns a single that will emit the list of airport objects once it's got the results back. So that's how we get that. Get departure dates, same basic idea. We just kind of forward to the API, which is like an adapter or mediator, get the results back. Here's find flight. So you can see these are all really very simple operations that don't do a whole lot of stuff. They just are called to get the work done. So now let's pop up here. Let's see, we talked about flights API. Let's go back over to the main view model. Now that we looked at what a remote data source is, it's basically just a way to talk to the server. And now let's take a look at how this actually works. And this is pretty cool because this is a demonstration of using asynchronous programming with RxJava. Now we're going to cover RxJava a lot more later in the class. So if this goes whizzing by too fast, don't worry, we'll cover it in more detail. But I just wanted to give you a flavor of how you can use this with an Android client. So what we do is we say...
Did you say that the Flights API was auto-generated with some kind of a Swagger generator?
I think it's using retrofit, I believe.
Retrofit. Okay, got it. Thank you.
So down here we say data source, that's the thing we just set up that knows how to talk to the server. Get airports, so we just looked at what get airports does. You can see it goes ahead and returns a single to a list of airports. And then we say, please run the get airports computation on an IO thread. So there's a thread pool called scheduler. There's a thread pool that's returned by schedulers.io, and that will then allow the get airports call to run off the main thread. So this will not run in the context of the Android user interface thread. It'll run in a background thread. And then the result of that will then be sent to the main thread. So what we're really seeing here is actually Rx Android, which is just an Android-centric variant of RxJava. And what it's doing is it's basically saying, observe and do the following process, everything from observe on to the end of this little chain of single calls. It says subscribe, and then we pass in some method references for handling success and handling errors or failure. And so, for example, all we do here, this is really cool. If you take a look at this, here's airport success. It takes the list of airports that we got back, and in the main thread of control, it tells the live data underscore airports object, please display the list of airports. So When it's done getting the list of airports, it's going to set that so that that's ready to go if somebody needs it. And likewise, if we get an error, then it just kind of goes over here to this method and it says what went wrong, depending on what the error was. So just some cool examples of RX Java. And what's nice about this is this code here runs off the UI thread because it's not intended to be user-facing. And this code here runs on the UI thread, and we get it to be there by using the Android scheduler.main thread method to say, observe this computation that follows on the UI thread. So I think that's really cool. So that's how we get the airports. If you look down here, we can log out. All these things look pretty much exactly the same. You do the logout operation. That's the one that's doing that call to the server to log out. You do that in the background thread, off the main thread, and then the results come back and you display the results. And the other thing we're doing here, by the way, is every time we create and subscribe to something, we're taking that subscription and we're adding it to something called a composite disposable. And that's basically a resource reclamation facility that will release all those things when they're no longer needed in one fell swoop. So that's pretty cool. If we take a look further down, yeah.
What's the, I guess, like main purpose of that over using like the Java garbage collector or something? Like how do those interact or relate?
Well, so the garbage collector wouldn't know that that stuff was no longer needed. We want to be able to get rid of that stuff when we're no longer need it, rather than waiting for the garbage collector to realize that, because it could be running in an asynchronous context, so it may not realize that it's no longer needed.
Okay.
So there's certain resources like memory that are well served by garbage collectors. There's other resources like socket handles or file handles or locks or subscriptions where you don't really want the garbage collector. It may not really know that it's no longer needed, but it's no longer needed. And there's a much more limited supply of those things. Like, you can only have so many open file handles before you run out. You're going to run out of file handles a lot faster than you're going to run out of memory. So you want to help the reclamation of those resources by giving them a hint or telling them to just go away. If this was C++, we would use destructors to do that, but it's Java. So
right. So that's why I thought it was kind of interesting, because I haven't done a lot of Java, but I know other languages, there's other ways to kind of manage this, but I hadn't exactly seen this with, something like Java where there is a garbage collector, but I wasn't really thinking about it in context of the file collectors or sockets, things like that. So that's really interesting.
Yeah, that's the way to think about it. These subscriptions are really not meant to live for a long time. I mean, you can see it basically lives from here to here. And when it's done, we want it. Well, actually, I take it back. It'll run as long as it takes to run. But when it's done, we want to be able to get rid of it, I guess is the best way to look at it. So we can do the same thing when we get flights. I mean, you're going to notice a very distinct set of patterns here. We want to find the flights. We do the find flights request in the background, and then we observe flight success. And again, this is the magic of live data programming with Android. It's basically the observer pattern in lots of different variants. And as things change, that just updates the appropriate part of the fragment that makes up the view, which is what the user sees. So I think that's probably about, there's also one for departure dates as well. And then if we go, let's see, try to see someplace where they call these things. So if you look at the fragment, for example, let's go look at airports fragment. If we take a look at that, you can see that when the view is created, so what this is saying is when we're starting things up, right? When the view is created for the airports fragment, we set up the listeners, we set up the observers, and then we go ahead and say, hey, view model, go get the airports, please. And that goes down here, and that makes the call in that background thread. And when it's done, it'll automatically update the appropriate part of that fragment to include the results. It's beyond the scope of this class to talk about Android programming in detail, but if you're interested, you can poke around and find you can take a look at the Android client. I'll post the URL to the Android client repository so you can play around with that if you're interested. It's super, super cool and really demonstrates quite nicely how you can have powerful capabilities on both the client and server side that used advanced techniques and can interface and use dependency injection frameworks like Dagger and annotation engines like Retrofit and so on in ways that are similar, though certainly not identical to what we see on the Spring side of things in the server. All right, so I think that was the main thing I wanted to show here. Again, there's lots of other cool stuff that we could look at, but now we're getting more and more into Androidism, and I don't really want to spend too much time on that. If you're interested in how the authentication and authorization stuff works, those are also handled here with things like the tokens and the token cache and the token repository, and that's all part of the protocol that's used to authenticate and authorize the client to make those requests on the server. When we get further along in the course, you'll see that there's different mechanisms that are used for other stuff. Like if you really want to be very modern and use microservices and you want those microservices to be exposed to the applications directly, then there's a slightly different security model you need to use. For our purposes, when we move to the microservices model, we're going to hide the microservices behind basically a kind of a front end and an API controller like sort of thing. And as a consequence, we don't really have to change the security model, but that's because we're not exposing the microservices to the clients directly. It's kind of hidden behind a controller facade, an API controller facade on the server side.